I put, okay, so you guys should see my screen now. Sierra, give me a thumbs up. Stevie, you guys see it? You're good? Okay, good. Thank you. Yeah, so we are doing some gas stoich work here. It's kind of a review. It's a culmination of everything that we've been doing here. So I'll put my little face up here so I can pause it when I need to. Remember, like you said, these are at STP. So these are the conditions that we need in order for this to work. Okay. So, and remember, just a review of gas stoich, or of stoichiometry goes gram to moles, grams of A and moles of A, and then you do your mole ratio from your balanced chemical equation. So you have BCE there, and moles of B to grams of B, and then you can get to liters. This thing got all jumbled up when I transferred it over to Google Slides. So I'll fix that up when before I load this up, and it's everywhere. Okay, so basically, so here is a sample problem, and this is a review from Stoich. So at the same temperature and pressure, how many liters of hydrogen gas will react with 4.5 liters of oxygen gas to form water? So first things first, you set up your little, since you're going liter to liter, you can just do a mole ratio basically, and you say how many liters of hydrogen will you get from 4.5 liters of oxygen, and this is just like your mole to mole ratio because we're at STP, so we can just use those numbers from the balanced chemical equation, and it's basically 4.5 times 2 will give you 9. Okay, so if you get a liter to liter question, then it's simple. It's just the ratio. Okay. The mole ratio from the balanced chemical equation, but you always have to check to make sure that your chemical equation is balanced. Okay. So here's sample problem number 1, and this is what I want you guys to work on your own. You can talk to your buddies about it. I'll leave the mics open. Just keep it clean. So sample problem number 1, you have methane burns in O2, produces CO2 and water vapor. A 1.22 liter methane cylinder at 15 degrees Celsius registers a pressure of 328 kilopascals. So that's the information that's given to you. The question that you need to answer is what volume of O2 at STP will be produced to react completely with all of the methane. So first things first, we balance the chemical equation because we know we're going to use that, and it's asking you the volume of O2, and they give you information about methane. Okay. So you got to get a game plan. So what you need to do with the information, give you the answer, what is wanted, what gas law, if any, do you use, and will you need to use Stoich? So you're given a volume, you're giving a temperature, and you're giving a pressure. And in order to do the Stoich, you need to have it in moles. So you're probably going to need to do something with figuring out moles. That sounds like a Pavnert question. And once you get that, then you're probably going to need to Stoich your way through it with just a liter to liter ratio using the balanced chemical equation. Okay. So here's the chemical equation that you were given. Your game plan is you're going to do an ideal gas law because you need to solve for N, right? So once you get, because you have to get into moles to use a mole ratio, and that's what Stoich's all about. It's like that mole ratio. Remember, that is a useful variable to have in this. So once you know how many moles of methane you have, you can Stoich to find out the volume of O2 that is needed, okay? Yes, because O2 is at STP, so you can use 1 mole is equal, or 1 mole is 22.4 liters at STP of volume. Okay. So this is what was given. Pressure 328 kilopascals. Volume is given. Temperature, once converted to Kelvin, is 288. Don't forget to do that. That's going to stay around throughout this whole unit that we're covering. And we're going to finish it up with a quiz at the end of this, starting next week, and then we're going to go into thermo. That's going to be our next. That's going to be our next little unit that we're going to do for distance learning. Okay. So once you rearrange this equation to solve for n, you plug in your numbers, you check it out. The number of moles is 1.67 or 0.167 moles of methane. Okay. Now you have that. You can go on to the next part of this, which is your answer from what you just did the ideal gas law for. You do your mole ratio, and it's a 2-to-1 in terms of oxygen to methane, and then you're going to use your conversion because the oxygen's at STP. 1 mole of O2 or 1 mole of any gas really is 22.4 liters. And so your final answer is 7.50 liters of O2. Part B, it's asking how many grams of water are produced. So we know that we had 0.167 moles of methane. We're going to do some Stoich, and we're going to switch from methane to water using that mole ratio. And then once we get into moles of water in this step, in the mole ratio step, we can find out we're going to use the molar mass of water, which is 18 grams, and then we can get our final answer, which is 6.02 grams of water, which falls within a reasonable amount based on the balanced chemical equation. And then they break it down. They ask you another question here. What volume of carbon dioxide at STP is produced if only 2.15 grams of the methane is burned? Can be solved 2 ways. So I'll let you write that down, and then you guys can think about, how to solve that. You can do it 2 ways. Okay, so it says what volume of carbon dioxide at STP is produced if only 2.15 grams of the methane was burned. And we want to find out how many liters of CO2. This is one way we can do it. Just some simple Stoich. We're going to go from this first step. Remember, we're going to use a periodic table. So it's 16 grams for every 1 mole of methane. We do our mole to mole ratio. In this case, it's 1-to-1. And once we're in moles of CO2, then you can use that conversion, which is 22.4 liters per 1 mole of carbon dioxide. And then you just multiply everything on top, the 2.15 times 1 times 1 times 22.4. Then you divide it by 16 grams. That'll give you your answer there at 3 liters of methane, or of carbon dioxide. So that's one way of solving it. The other way is you could Pavnert your way through it, and once you're going to use a little Stoich here, you get get it into moles, and you get 0.134 or 0.134 moles of carbon dioxide, and then you plug that into your Pavnert equation that you're solving for volume. You plug in your numbers, and you get the same answer. Okay, so some of these you can work 2 ways. Don't get stuck on one. Kind of think your way through it, because they do want us to increase the rigor of your classes, having you guys think a little bit more, especially as I think this is the 1-week anniversary of our quarantine, of our shelter in place. So you guys are probably getting a little a little stir crazy in the house, having a little cabin fever. So we're giving you something that'll get your mind off of those things and help you think a little bit more. So this is two ways. So let me see if I can do something here. All right, so see if you can solve on that. Okay, so I already did that conversion here at the bottom. I remember I switched this up last year and kind of changed things out, and this works better live when I can click through the slides, but I'm afraid it's going to kick me out of what I'm recording and all of that. So I'm just going to do it like this till I get a better handle on it. So you're going to go into moles of hydrogen first, and then you're going to do your mole ratio, and that's how many moles of ammonia you have. And now that you have that, now you can Pavnert your way out of that. Am I going too fast here for you guys? Yes, no? So that's giving you moles of ammonia. Now you need to find out the volume of ammonia. So now you're going to use the information they gave you in the problem here. Okay. So first you had to Stoich your way through and just find out how many moles of ammonia you're going to need. So that's how you're going to marry the Stoich and the ideal gas law on these types of problems. You can use a Rika table for it too. I mean, it's just, I know it says that on the form, but this was made without Rika tables in mind. So anyways, so we got our answer there, 2,475 moles. We put that in for N. We're going to use kilopascals, or the 8.31 gas constant, because of the unit of pressure, which is kilopascals. You write all of that in there. And of course, your temperature's got to be in Kelvin, divided by the pressure, and your volume should be 16,135 liters of ammonia. Okay. The gas Stoich, depending on how it's asked, if it's a simple, liter to liter, then you just go like sample problem one. You just do like we did right before the break when we were doing Stoich. Okay, it's basically the mole ratio, right? It's a liter to liter. If they're asking you to, go from one gas to the other, and they give you all this information, except for one variable in the ideal gas law, then you're going to have to do a combination of both. You're going to have to Stoich your way through it, and then find out, how many moles or whatever it is they're asking for, and then solve for moles and Pavnert or volume, just like those two examples that you had there. So that's kind of as hard as these can get as far as the rigor in this unit. So is there any questions? Okay, so look on Google or Skyward to see if you're missing something, and if you did it, just click that you turned it, click to turn it in. That way I can get that feedback from in Google Classroom that you've done it. So I just went through. I was up late last night since they told us, the grades are. This is what you're going to do with grades. It was a little more solid than what they were saying at the beginning. So that's I went through and put all that stuff in there. So it could just be that you just didn't click turn it in, and you did the assignment, and I just didn't get that feedback from Google Classroom. So go through that. If it says complete and you're good, then you're good to go. If you can tell me what it looks like if you're missing something, what it looks like on your end in Skyward, so I can know how that's working now, I would greatly appreciate it. And then I'll look through your emails and your question. I know there was a question in the chat that I need to address for somebody. But anyways, it's great seeing you guys. I hope you guys are staying safe. Go outside for a little bit, not around people, but go for a walk. There's trails in the green belt. go out there. And I know me and my son are looking forward to the rain because we're going to go out on our bikes, and we're going to get real muddy on the trails and have some fun. So that's how I'm getting away from all of this. Otherwise, I'd go bonkers. All right, but it's really good seeing you guys. And then if you have any questions, shoot me an email, and then and we'll adjourn again on next Tuesday. I'll load up everything that's going to be due probably Monday morning, starting next week. We're going to end this gas unit with a quiz. I'll put that quiz up for you. It's a quiz, one that you can do as many times as you want. And I get those are the easiest for me to see your grade because it tells me right away. The Google Forms is a little extra step that a bunch of you guys aren't doing. It's just a click to turn it in or submit when you're done, so I can get that feedback. All right. So I hope you guys are good. If you have any suggestions that make things a little bit easier, if you have a teacher that their flow of their classroom is easier online, just let me know. I'll shoot them a message, hey, what are you guys doing? My kids really like what you're doing. If it's working, you're good, then, you don't need to say anything. But any feedback is great. All right. So I'm going to let you guys go. Enjoy the rest of your 1 week anniversary in the shelter in place. All right. See you out on the trails. What is going on here?